Hello, Linton Herbert again, and we are, as it were, making a universe. What would it take? And as I've explained before, the game here, and this is only a mental game unless someone has enormous resources to pursue it. Um, the game is to figure out what it would take to produce a universe that pretty much resembles our own with minimizing the number of things that you have to introduce that look like pure magic. And in the usual formulation, as we've seen, there's a lot of them. If you go to nobabies.net and look up the scripts for the videos, uh, no, it'd be look up Kim, the Kim talking Heidelberg. You'll scroll down a bit when you get to the home page. And there I've got the things that just seem like pure magic numbered, and and then later the numbers of the times we've accounted for things without having to stoop to such things. Anyway, so here we are, second um, fourth in the series. Um, uh, about the universe. Uh, I usually, when you go on the internet, you'll find people doing what I'm doing now with great youth, physical vitality, and coming through with programs virtually on a daily basis rather than weekly or monthly. And truly, I would be happy to give you more faster if I could. Where are we? All right, Alan Turing. Um, you may want to look up Alan Turing sometime. He came up with what is called the Turing test, uh, which basically means that you get a computer, you put it in touch with, at the time was a teletype, and you have a teletype, you have a person sit at the keyboard of the teletype and tell him, okay, well, you get three teletype machines. One has a human, one has a computer, and one has the human doing the judging. And so you, at random, have the person doing the judging talk to one or the other of the one or the other of the two remaining teletypes, and his job is to ask questions um, that will test whether the person at the other end of the line is a computer or person. And if he cannot tell, then then the computer is by definition conscious, aware, and a functioning as a human being. Now, Turing was one of the brightest people we know about. He was he was into using computers to crack codes, and he was amazing. Well, he came up with things like first thing you do if you've got a German message, this was World War II, if you say, okay, let's just say the last words are Heil Hitler, and then you look at the rest of the program and see if you can now figure out what the rest is, knowing those two words. Well, Germans, I think, finally caught on to that trick. But he had a bunch of tricks, and he has very sophisticated and subtle ways of pursuing the matter. He had equipment that had been taken off a submarine, sunk German submarine, that gave him a good handle on the way things worked. But he was bright. He was gay, bright as a whip, bright as a whip. And that was the Turing test. Another thing Turing did um, uh, was the was to prove that, you remember, we previous talks we said, okay, we're going to introduce one proton, one neutron into our universe, and then we would introduce one doohickey, a thing that's conscious and is able to remember, at least partly able to use abstract reasoning. And Turing, among his other major accomplishments, was he proved that you cannot have the doohickey in here, in this universe. The laws of logic, the rules of inference, won't permit it. Not in this universe. Um, but um, so the in here, within the knowable universe, the laws of science hold, and abstract reasoning is impossible. The doohickey, which is your mind, it is what is conscious of me talking, is it's not there. It can't be scientifically. Well, that caused a problem. So people remember the Turing test. Oh, yeah, right, we're going to have intelligent machines. They ignore the countervailing thing that Turing proved with a mathematical proof. The test of how, whether it's consciousness or not, depending on somebody's decision, somebody's judgment, depends a whole lot on how bright the person making that judgment is. They have, nowadays, you have computers recognize things. Some very clever people took some pictures like of a 3D printed turtle, and you look at the picture, and yeah, it looks like a turtle. The eyes aren't quite right, but it's really a pretty good turtle. And you give it to the computer, and the computer says it's a rifle. Well, what they did was they got in there and figured out exactly how the computer was processing the information on the picture, and they introduced changes in gradients and so forth so subtle the human eye can't even see that they're there. But the computer can see they're there well enough to say, oh no, it's not a turtle, it's a rifle. Um, well, you put that kind of mind up against a keyboard and say, okay, figure out whether it's a computer, and he'll be hoodwinking that computer pretty quickly. So yeah, um, I think Turing really thought no one's ever going to be able to trick people into thinking they're dealing with a mind when they're not. Anyway, he proved that the mind, that is to say, the capacity for abstract reasoning, cannot exist in a world governed by the rules of inference, the laws of logic that we all live with, and of course, the science is. Um, uh, um, so the doohickey is like um, that proton, the neutron. Remember, it bounced around. All neutrons are alike because it's all the same neutron going back and forth all the time. All consciousness is alike because it's the same consciousness bouncing back and forth in time, into the knowable universe, and then somewhere in the unknowable universe bouncing around, and another version of it being pulled in and again and again. So be nice to people. The person you're dealing with is you at a different point along the path we're all taking. We're all the same consciousness. And it's not just people. I swear, I have lizards on my porch, and reptiles get a lot of bad press. But my lizards are sensitive. They are aware of themselves and of those around themselves. They deal with grief. They understand other people's grief. Oh, you think I'm out of my mind, don't you? Well, quite possibly. But that's my impression. I don't think lizards are beneath contempt. The reptilian brain, at the bottom of your skull, which is only makes only makes the simplest decisions and is cruel, and it's only the frontal lobes, the big overdeveloped part of the brain that's able to understand things like socialization. I'm sorry, I don't buy that. The reptile brain, and oh yeah, the reptile brain has instant reflexes. Really, you put a dog against a snake, that snake's gone. The dog has far faster reflexes than the snake. He will strike at the snake, and before the snake can react. Oh, but a dog has all this. He's got all this overdeveloped brain. He's able to be sociable better than the lizard. All right. Let's see. So out there, outside the knowable universe, time goes either direction. There is no difference between good and bad, help and harm, creation and destruction, because time. I help you in this direction of time, and the other direction of time, I'm harming you. In here, it's different. Somehow, um, there is a we all agree on the direction of time, and therefore we can all agree on what is good and bad, helpful and unhelpful. I know you think this is unhelpful, but I'm trying to be helpful. Okay. Um, uh, so the whole point of the matter, the whole reason there's universe, or at least one side effect of it, is the fact that in its many trips through the universe, through the in here, the doohickey, the one great doohickey, has the opportunity to experience both sides of an enormous number of personal histories, um, and is thus able to perceive a moral order. A moral order cannot be defined or imagined except with such a universe as we have with its direction of time. Yeah, you gotta love this kind of machine. Okay, so here is an example of the doohickey at work. This is the late, well, he's one of the Rockefeller clan, and yeah, well, there he is. He has lived a long life at this point. He's done a lot of stuff. He's had a lot of resources. And here's a man named Soros. Try that again. We got him. Kind of creepy, isn't it? I mean, not that these are creepy men particularly, but the degree to which they resemble each other. I mean, it's like, oh, well, maybe it really is the same person. But it can't be, according to the usual rules of reincarnation, which is that you get created as a person, the soul is slapped in there, the soul lives through the life story of that person dies, the soul, unless it achieves some mystical escape, gets placed back into another person. Well, it's the people tell you this is between Asian time and Western time, but no, they're both linear. No, what really is happening is that these two guys are the same guy. Now you're talking weird time. Um, and then here are a couple people. Here's a young man, dead, but young. And here is an old man, old but alive. And these people, these men, live thousands of years apart. So they could be the same person according to classical incarnation. You know, incarnated, died, waited 2,000 years, came back as this person. Okay, I don't think anybody believes that, but logically it's consistent. Much more so than these people who are simultaneous. Only way you could have the same person, it's the same doohickey in two people is to hop outside the universe, come back in on a different timeline. All right, so how are we doing here? Now then, so which way is it going? Um, um, if you are in here, right, in the known universe, you see something drop into a black hole, then, all right, then you know which way time is going, because it can't go from outside the black hole on Monday and inside the black hole on Tuesday in one place, and then elsewhere be outside on Tuesday and inside on Monday. There is a specific direction of time. As soon as you see a black hole swallow something, you say, oh, all right. The real future is in the direction in which the thing was swallowed. If it was spat out, then you'd say, oh, that's in the reverse of normal times, the reverse of normal expectation. Well, these are tracings of gravitational wave coming from what they reckon was two black holes spiraling into each other. And as you see, they come along, okay, they find there, and as they approach, they orbit around each other, and the orbits are getting shorter and shorter and shorter as they spiral in on each other. And the amplitude is getting bigger and bigger as the acceleration increases. So goes around, and then bang, gone. Yeah, all right. Maybe that would be evidence that, and this is going Monday, Tuesday, Wednesday, that would be evidence that, yes, things fall into black holes. We've got an example, and time is moving the way we always thought it did, and Herbert is completely wrong. All right, well, there's some evidence. When I look at this, I'm not so sure. Look at this. You see that? That's of lower amplitude than this, and then it drops down even more. Basically, these things are symmetrical, where they're distorted. Okay, good. And you could wave your arms all day or saying why so many cycles seem to have happened here but not here. But the fact remains that it looks like you could run this either direction, forward, back. It doesn't tell you which direction time is going. I'm sorry, I'm unimpressed. Let's sit here and, we'll talk about the details, but ultimately, that's Mike. And you can see that it's both of the gravitational waves becoming muted after the maximum spike and then dropping further means, sorry, this, oh yeah, they've got a, quote, black hole, end quote, dropping into a, quote, black hole, end quote, doesn't tell you whether, it doesn't tell you which direction time is going. Okay. Okay, let's see. Uh, we see background noise with oscillation emerging. Um, we see the black holes are different, um, of different sizes. All right. The heights of the peaks alternate, higher and lower. Yeah, the oscillation speeds up. Okay, good. The waves get higher. Yep. These are things you'd expect if time is going the way everybody's always believed. The holes themselves swallow more and more of the energy. The waves start to get lower. All right, you see how that would work? Here, you could say that the waves are getting smaller because the system, this super black hole now, is sucking energy out of our universe. All right, well that works. And um, things slow down as gravity slows time down. All right. Um, so the, the thing passes a half dozen tests, but it's symmetrical. So now you're having to talk about just how much of a change. So we are um, uh, still not identifying something unambiguously on Monday and watching it drop into a black hole and be gone on Tuesday. Um, that has not yet been done. Maybe tomorrow, or maybe tomorrow will wind up and the whole universe will come to an end. All right, next talk we will be talking about the Bell's inequality, one of those things that where people get bent out of shape, but it's not that difficult. I'll explain it to you when we get there. Okay, well, have a good one. Um, the and remember, be nice to people because that other person isn't just like you. That other person is you. Don't be unnecessarily cruel because yeah, you'll get it back the other side. Nothing magical about it at all. The eternal quest of man for the cursor. It is. Right. Or woman for the cursor. Gotcha. Have a good one.